All right, today we are on part 2 of working with sine and cosine graphs. And let's remember that there's this connection between our circles and the waveform that it makes, this yellow wave line that it makes as we kind of rotate around the circle. So remembering that our sine and cosine waves look like this yellow shape here. Another quick review, and I've thrown this on the top of our note sheets. Okay, we can change that sine graph and that cosine graph for these various transformations. We have A, which corresponds with our amplitude of the graph, right? And that's the distance between the midline and one of our peaks. We have B, which is going to change the period. We're going to focus on that today, and that is the distance in between our peaks. Talked about it a little bit yesterday. That can also be the distance of one full rotation. And finally, D, which is that vertical shift of the midline. And our midline is right here. And so basically wherever that shows up on our y-axis, that is going to be the equation we have for our midline. So that's just a quick review of what we've been talking about. Now, we didn't do really any work on period the other day. So today's focus is going to be on that. If you were in class, we already did some exploration where we read the period from the graph. Now we're going to be able to calculate it from the formula as well. So if we look here, our period formula, let's write this down, equals 2 pi over b. Basically that's saying, all right, a normal circle goes around once every 2 pi. That's a normal circle, right? Well, if we want to kind of rotate more frequently than that, then we are going to modify how quickly we go around 2 pi by dividing it by some coefficient. And that coefficient is b in our formula here. So when we're calculating the period, all we got to do is locate b, which in this case is 4, and calculate it. So we get period equals 2 pi over b, which is 4 in this case, and we can simplify this down into pi over 2, and that is the period of our sine wave. Can repeat that for example 2, basically locating b, 2 pi over 6 is going to be what our period is equal to, and so that can simplify down into pi over 3. And last one here, our b coefficient is equal to 2, so our period is equal to 2 pi over 2. And if we just simplify that down, we're left over with pi over 1, or a little more simply, just pi. Now, reading the period from the graph. If we go back to our definition, you'll notice that the period here is the distance in between the two peaks of our sine wave. But we'll notice that if we were to measure the two peaks of this sine wave, we have right here and right here, that's one period. We'd have an interesting problem to do. We'd have 5 pi over 2 minus pi over 2 would be what that is. 5 pi over 2 minus pi over 2. If you actually did that math, we would have 4 pi over 2, and that would just be equal to 2 pi as our period. So there is a slightly easier way to do this problem, and this is the way that I recommend how we do it. We notice, okay, I am starting at a value of 2. And if I trace my graph for one full rotation, so I go up, I don't stop here because we haven't gone all the way around yet. I need to go up, then down, and back to our starting point. Okay, there's one full rotation here, and this lines up with a value of 2 pi, so our period is equal to 2 pi. Notice how I didn't stop right here. That would only be one full rotation, right? I've only gone up. I need to go up, then down, in order to get to one full rotation. So let's try this with example 5. And this one is going to have a different period. It's a lot more waves happening in our entire kind of frequency here. Let's start with my tracing way. So we know that we're starting at a value of 1, all right? And we want to get back to 1. So our graph goes up, goes down, and right here at the bottom of this peak is when we've hit one full rotation, and that lines up with pi on our graph. So period is going to be equal to pi. If you wanted to do this a different way, you could recognize that, hey, I start peak to peak. On the bottom peaks, I start at pi and 0. So we have pi minus 0 equals pi. You could also pick another peak later down the road if you wanted to. Let's say we went from here to here. We'd have 7 pi over 2 over 5 pi over 2. 7 pi over 2 minus 5 pi over 2. And that would be equal to 2 pi over 2, which is just equal to pi. So you can see that no matter what, the 3 different ways, you should get the same answer. But this one, the tracing method should be the quickest and easiest way to get there. Now, let's just do a couple examples where we're going to put everything together. So we've kind of ignored the equation of the midline, we've ignored the amplitude, and focused on period today. But we want to go through one time and just find all this information from the formula. So if I do that, my equation of the midline, that's associated with that d coefficient. So it's at the end of the equation here, it's 2. So that equation for that midline, that horizontal line, will be y equals 2. Okay, our amplitude is tied into that a coefficient out in front. So that is simply going to be equal to 4. And then that period here, we have a value of b, or b is equal to 3 here. And so if we plug that into our period formula, we get 2 pi over 3. And that's actually something I don't even need to simplify because it's already simplified down as far as we need to go. All right, then we can also do this, find everything with our graph, right? So we got a new graph up here. We're going to find all the information we need in this problem. So first thing I should do is find that equation of the midline. I can see that the line of symmetry here is at 1. So my equation of the midline is simply going to be y equals 1. My amplitude, if I measure any of these peaks, let's measure one on the right so that we have some space to make other notes. Looks like it goes up 1 tick mark, 2 tick marks, so we should have an amplitude of 2. If I wanted to check this and make sure I got my midline right, I could double check that with one of our down peaks, one of our valleys, and see that, hey, I got 1, 2 spaces as well. And finally, the period. I'm going to use that tracing method. So I know I start at 1. And I'm going to trace my graph that we go down, we come back to our starting point, but we don't want to stop here, right? Because we want to get one full rotation. So we up again, down again, back to our starting point. And that lines up with pi. And so my period is going to simply be equal to